because I saw the other guy having it, and I was like, is it okay?
It's preference, so we have both.
Oh, cool.
Yeah.
Thanks.
So we have to be like really quiet with the volume because the only thing separating us from the other rooms
Is the
curtain.
curtain,
So
yeah. So should I just practice volume and
yeah,
stuff?
you can do that.
Do you have the notes that I sent? That
Yeah.
sent you? Okay. Do
Yeah,
you need
yeah.
them?
No, I already met the people, so I'm like, I'm going to give them the introductions that they want. So
No worries. No worries.
Yeah.
Just checking if you have everything.
no, thank you, sorry.
Yeah. Yeah, I'm just. Yeah, it's on. I just.
It's part of the
Everyone, welcome back after lunch. Just put your hands up if you had a beer or a free drink. Yeah, like I'm seeing lots of hands up. You probably had a great lunch. Welcome to the afternoon session. I'm really excited to meet all of you. My name's Bilal. I'll be hosting the web stage today and the rest of tomorrow as well. But you're not here to see me, right? You're here to see the person who's about to speak. But the person who's about to speak, let's give them a round of applause, said to me, they don't want me to read their bio. They want me to just give a fact. You said a fun fact, right? You said a fun fact about yourself, which is something I've never heard in my life. So put your hands up in the room if you've ever done spider fighting before. Yeah, you're all like, what the hell is that? That was exactly my reaction. I asked Devlin to charge my phone over the break, and Devlin said, yeah, but the fact about me is, like, I used to fight spiders when I was younger. I hope your talk is entirely about this. I'm sure it's not, but there's going to be something way more interesting as well involved, because he said he's not going to talk about just one, but two things for you this afternoon, so you've actually got a special treat in store. So can you put your hands together? I know we're a small audience, but we're going to make a lot of noise. So we're going to practice this first. Like, firstly, I want you to say, woo! Nah, that was pretty terrible. We're going to try again. Woo! Put your hands together and say woo for Devlin Doodle-Dow. Thank you.
Okay. Do I need test mic? Test mic. I have two mics here. Test mic. I have.
Use the ear mic and I'll take that.
Hold on. Mic test 1, 2, 3. Mic test 1, 2, 3. It's good. Good. Sorry about that. I got confused. Bilal handed me the microphone. I have mic here. But anyways, yeah. First of all, I'd like to thank you for coming here, spending your time with me, learning new things. So yeah, also like to thank all the sponsors. Without them, this is not possible. Every one of you. So this is about Turbo Pack and RS Pack. The title seems different than what you see right now on the screen, because I want to add another JavaScript bundler written in Rust. So that's gonna be like better version of what it used to be, since there are now two things here that I'll be discussing. So a little bit about me. I'm originally from Manila, Philippines. Been living and working now in Oslo, Norway for 4 years. I'm a Microsoft MVP working for Meta, which is an IT consultancy. And I've written some books in 2011. That was my first book, and another one after a year, and then another one after a year. So full stack, Spring Boot, Angular, ASP.NET Core, Vue.js, and then another one, TypeScript, React for enterprise application. But anyways, so much for that. Let's get it on. So you see here a car design that shows you different pieces that were put together to build this car, right? So similarly in software applications, these pieces are called modules. So you can also say that for example, in React or React components, these are the building blocks of React application, right? Creating modules to build software or a car gives benefits like, first is isolation. So it allows people to work individually on the car or on the application, without delaying someone. Another one is composability. So clear boundaries for each individual component. They're able to compose each piece together to create a fully functioning feature, right? Another one, reusability. reusability can reuse the same components. For example, in this car, that would be the wiper, the wheels, the seats, etc. Right? Another one, another benefit, organization. So the effect of each individual piece having clear boundaries for how they interact with each other benefits us. So how do we do modularize, or how we modularize our code before? First, or in the beginning, there's this IFI, or immediately invoke function expression. It mimics a module scope. It hides variables, self-contained, etc., and it helps us create module pattern back in the day, right? And in this example of IFI, the X variable is not visible outside of the IFI, so trying to log it outside of the IFI function results in a reference error. The next is, after IFI, CommonJS, so built for Node.js originally and synchronous. And then after CommonJS, we have this asynchronous module definition, which is AMD. AMD, example of AMD is required.js. So AMD fixes dependency resolution and pollution of global scope. We use this AMD and CommonJS to share libraries through NPM packages. So this is the start. So how do we use CommonJS in the browser if it's built for Node.js and it's synchronous? We have this for a while, Browserify. So Browserify is made to support CommonJS in browsers. It is a module bundler that needs, or that reads all requires and module exports and bundle all JS files into one JS file, right? Or bundle.js that you often see. Browserify needs gulp and grunt though, or these are task runners, by the way, to run. So there's a little bit of cons about there. Then after Browserify, we have Webpack. This is a module bundler, right, that can do things that Browserify can do, such as detect the code you don't use to exclude it while combining files, serialize the code and load it only when it's necessary, right? Monitor file alterations, and of course, it has a transpiler, which transpile code to ES5 or other things. And another one is it can concatenate multiple files together in a single bundle for the browser. The problem that Webpack has, it's the process becomes increasingly slowly as your application grows. And you would notice that if you have a large React application or let's say Angular application, the HMR or the hot modular replacement takes 5 seconds, 4 seconds, 10 seconds if you have a shitty machine. Oops, I'm not sure if that's possible. But yeah, if you have not so good Windows or MacBook, you know the drift. So let's go here. First will be TurboPack, written in Rust by the creators of Webpack and Next.js at Vercel. So this is the new one. So TurboPack delivers a swift and versatile development experience for applications in any scale. It doesn't matter how large the application is. So the idea is make the HMR as fast as it could, and it shouldn't change, depending on how large the application. It doesn't matter how big, as long as it stays like in a milliseconds. So that's the idea. That's the goal. But yeah, why TurboPack again? Aside from HMR, incremental by design. So building once is enough work. Once TurboPack performs a task, it never does it again. It's like there's a built-in cache within it. Ecosystem friendly, so you get out-of-the-box support for TypeScript, JSX, CSS, CSS modules, WebAssembly, etc. And lightning-fast HMR, which I already mentioned. Hot module replacement, right? Another one, React Server Components. So support for RSC, which is the future of React. And simultaneous multiple environment targets. So you can build and optimize for multiple environments together: browser, server, edge SSR, React Server Components. And Next.js support. Let's move this because it's being built under Vercel. Of course, it's just not surprising that by default it supports Next.js. So why replace Webpack aside from it's getting slower as your application gets larger? So Webpack was created 10 years ago, retains its dated architecture despite web development significant growth. Another one here, plugins. You know, it can do anything. Backward compatible. So large changes are hard to do. There's another one. And cache invalidation, too sensitive, incremental builds. Cache lookup helps skip redundant work, but with many modules, it can lead to considerable cache lookup costs. So these are the main problems in Webpack. Now let's move on to the architecture of TurboPack. So Vercel created a layering system under Rust as the base. So the base of this TurboPack bundler will be the Rust programming language. So why Rust? Rust offers parallelism, more control of memory allocation without being painful as C++, and it's all about the security, right? But it's more challenging to write than JavaScript. So let's face it, JavaScript is easier, especially if you already know JavaScript. But to encourage plug-in development, Vercel supports both JavaScript and Rust for plug-in interfaces. So anyone or all developers can start with JavaScript and then port it to Rust afterward. So another one here, next layer, Turbo Engine. So a core engine for common tasks like caching, invalidation, and incremental builds. Vercel is also using SWC. This is a modern transpiler built in Rust that replaces Babel. So instead of the Vercel team creating their own transpiler, they just use this SWC, by the way. It's an open source transpiler, and it's also written in Rust. So that's a big time saving for them because they get to use someone else's work rather than them creating it alone. And then the TurboPack itself. So a bundler handling CSS, static assets, WASM, images, fonts, and more leveraging of the SWC. And then the support for Next.js and other frameworks that can use TurboPack as a bundler. But right now it's just Next.js, but the plan is to support React, Vue.js, Svelte, Angular, and so on. So why TurboPack is so fast? Let's look at here. So TurboPack's impressive speed is attributed to incremental computation engine. So in a typical bundler here, the process, you see here, the bundler, the process involves reading the files. You can see here, both of these, and then bundling them. I hope you can see here, my mouse. And then concatenating them, see here, and then performing multiple tasks to create this full bundle, right? However, TurboPack TurboPack takes it in a different approach by keeping track of the inputs or caching it and outputs of each function. So during the first run, it reads, bundles, concatenates the files, and remembers all the outputs. On the subsequent run, or subsequent runs, if a specific file such as SDK.ts, for example, this one, let's say it was modified, TurboPack only needs to redo the steps related to that file, here, as you can see here, and it doesn't need to read or bundle the unchanged files like API.ts. So this incremental computation and the native speed of Rust are the responsible for TurboPack's speed performance. So it's just going to rebundle all the files that have been changed. It doesn't rebundle everything, right? So interestingly, the Turbo engine itself is not involved in the bundling process. Its main function is to save, again, the results of the function, the output, which is like a cache. So that's the architecture of TurboPack. Getting started with TurboPack, just have to run the command npx create next app with TurboPack as a template. And then you would notice after running this npx script that inside the JSON, the package.json, you will see this dev script here with the flag next.js dev with the flag -- turbo. So meaning it's going to use TurboPack as the bundler for your next.js application. Just a warning here, though, in TurboPack, if you're building application using RSC or React Server components, TurboPack doesn't support it yet, at least this time. By the way, let's see a month from now or 2 months from now, but right now, you would see some errors or warnings in your terminal that, sorry, TurboPack doesn't support RSC yet. So that's TurboPack. There's no like demo I can show you because this is just a bundler. If I bundle the Next.js application, it will be the same application that you would see if I demo a Webpack, right? So let's just move to another JavaScript bundler written in Rust, which is RSPacked. So ByteDance and Valor Software introduced RSPack to the open source community. And if you haven't heard ByteDance, that's the tech giant behind popular platforms such as TikTok and Douyin. And they open source. They're actually dog fooding their own source code, their bundler. So this is what they're using in that platform, RSPacked. So let's check it out. Why is it so, getting this popularity? So fast startup, that's one, same as TurboPack. Pretty much the same. Lightning HMR. So it's the same also. So basically the same. And I will show you later what it makes the difference between TurboPack and RSPack. But if you're gonna ask me, performance, almost the same. And the features, right? They support TypeScript out of the box, Lightning fast HMR. But let's talk about Webpack compatibility. So if you have written React application with Webpack configuration and you know how to configure Webpack, that skill won't go away if you try RSPack. Why? Because RSPack supports Webpack configuration out of the box. But not all. By the way, you cannot just copy everything in your Webpack configuration and expect that it will work in RSPack. They have 100% compatibility support, but there are still pieces there that it's still at the work. So, yeah, this is the main difference between the two. In TurboPack, it's not using Webpack, but RSPack it's fully compatible and you can use this. Okay, aside from that, batteries included. So again, TypeScript, JSX, CSS modules out of the box. It works. Production optimizations. So it optimizes caches. So same thing as in TurboPack. And this is when they release it. When they release a stable version of RSpec, it's framework agnostic right away. So you can use it in Vue.js and React as of today. So how do you get started with RSpec? npm create RSpec at latest to get the latest version. And you will see in the package.json, you have this script dev RSpec serve. So it will just run your React application. And just to show you a little piece of what I'm saying earlier, Webpack compatibility is when you open up the boilerplate, the source code or the repo that you just generated from RSpec boilerplate generator, you would see this RSpec config. I'm not sure you see it there, .js that it's similar, but actually it's the same configuration that you would do in Webpack. So, stable and battle-tested bundler. Let's say TurboPack, it's still in beta, so I wouldn't recommend using that in production. What about RSpec? Let's say yes and no. Yes, it works for TikTok, but I wouldn't say also, let's say, it's too early to tell because Vite, JavaScript bundler, is going strong and a lot of support is being done in Vite. And what I can recommend is if you're going to write application today and thinking of replacing Webpack with much faster bundler, I would highly recommend Vite. Vite has been, for 3 years, I think, since 2019, 2020. So again, this is just an opinion from me. Choosing between TurboPack, RSpec, I wouldn't recommend it. I would go with Vite for it's battle tested, a lot of support. You can do a lot of things with Vite, and they're solving the same issue that developers are experiencing, which is lagging in seeing the changes when you change something in the front end, like for example CSS or JavaScript, and then expecting that it will show up on the screen in a few seconds. Well, this bundler does that perfectly, and it doesn't matter also how big is the application. You get this O of 1, in speed, in terms of speed, that constantly, it doesn't matter how big the application. We have this constant number of how fast the HMR will be. So, just to summarize, TurboPack and RSpec, they're both Rust-based bundlers, lightning fast HMR. RSpec has Webpack compatibility, while TurboPack does not have. TurboPack and RSpec provide improved DX or development experience or developer experience. And Vite is the most mature bundler as of today, which is not written in JavaScript. So, resources. I would recommend going to these links, turbo.build/pack, rspec.dev, and vite.js.dev to get this, a better DX when you're writing application, modern application as today. So, that's it. Thank you for listening for this quick introduction about RSpec and TurboPack and why you should use these bundlers here for giving you better development experience. Thank you. And if you have questions, you can ask me questions at the back. I'll be there. So, yep.
Okay, thank you everyone. Let's give another round of applause for Devlin. Devlin, shake my hand. Great, thank you so much, Devlin. Put your hands up if so far today, doesn't have to be right now, but so far today you've learnt something. Yeah, there's loads of hands up. Put your hands up if so far today you had a go at the Porsche thing out there. Two people. I'm really jealous. That's my plan for tomorrow. So definitely put your names down if you haven't done that already. But we have another talk lined up for you. So if you are here, ready to see Mattia, I'm really excited to introduce Mattia, who's a CEO and co-founder at Wasp. Mattia's founded that with his twin brother, which is a nice fact, actually. This is the second startup that they started together, funded by Y Combinator and Top Deep Tech funds in 2021. His background is an MSc in computer science from the University of Zagreb, and his previous work spans from Research Institute in Singapore to top growing startups in New York and London, which is my home, as you can probably tell my accent, covering fields of bioinformatics, mobile and web development. So Mattia said that he's going to introduce himself a little bit more than that, but without further ado, can we give a massive round of applause for Mattia?
I was like, well, wow, okay. And no, I mean, the snail kind of took it all the way. But the good thing is that we have a lot to speak about today. So otherwise it will be pretty boring. So yeah, let's get started and see what actually happened. So first of all, let's kind of put all the language stuff and Haskell stuff aside. Let's just focus on the web development. I mean, after all, we are on the web stage. So I mean, why? So why, after like in this year and age, like why create a new web framework? Like everybody knows, like they're always coming, popping up, left and right, popping out, and kind of it's a joke already. Everybody's creating new frameworks. Developers hate it. So why do it at all? So here's why. So this is the search I did in Google yesterday. So we see here two main reasons to do this. So first thing, what it says, why is web development important? So even, we have GPT today, and we're all developing cool AI applications, and but whatever you do, whatever space algorithm you develop, in the end, you need to deliver it to your end user. And the chances are you're going to use a web application for that. So that means web development is important, and we should actually have, proper tools and give it the proper attention. The other thing is the one in the orange box. So even today, in 2023, when you Google for web dev, the first thing you get is why is it so hard, why is it so messy, why is it so complicated. So obviously, even we have all the tools that we have and the space is better than ever, the developers still have a hard time. So that means like we still have work to do, and we can still do better. So this is why we need to do this, except for the snail's wishes. Awesome. So let's move on. Okay. I believe everybody's here quite familiar with web frameworks and that part, but what about DSL? So let's maybe do like a quick show of hands. Who has heard of a term DSL in the context of programming before? Okay, nice, quite a bit. Okay, but let's still do a quick intro to it. So even if you haven't heard of the term, you probably use a DSL every day. So even if you are not familiar with the term, let's say you're probably very familiar with this bad boy. So this right here is a regex for validating your email address. It just works. You say what you want, and it makes sure it works. So regex is a DSL. Let's move on. So this one, you're probably also very familiar with. Good old SQL. Has been around for the last 20, 15, 30 years, whatever, and we are still writing it in some form. Is it ORM, library, or something else, but we still deal with this on a daily basis. SQL is also a DSL. And finally, the sugar for our web dev stage, a good old JSX, letting us pretend we write HTML from 2013. Awesome. So all these three examples we saw, they have one thing in common. So all of them are languages. But they're not any kind of languages. They're actually very specific, which means you cannot use this language, like you cannot use a regex to implement a graph search algorithm. If you can, you shouldn't. Also, you cannot use SQL to render your web layout. So that means they are created to do only a single thing. And they are meant to be used only in a single domain. Which, for regex, it's like text search. For SQL, it is a database querying and mutations. And for our JS6, it's obviously templating and web rendering. So this leads us actually to the definition of a DSL, which means a domain-specific language. Awesome. So now we got the definition out of the way. So what next? So you will see I keep asking these why questions. That's kind of my thing. And then I answer them myself. So I'll keep doing that. OK, so why? We now saw that DSLs exist, but why should we actually go to the hassle of creating one? Because after all, it's a new language. You have to create a new tooling for it, people have to learn it, you have to make all the syntax highlighting, all the fancy stuff. Why not just use, some existing language, make library in it, and, you are done. So let's actually see why. So I'm also big on movie references. So it's not that you can't handle the implementation, it's more that you don't really want to handle the implementation details. So DSLs, they have this kind of magic around them. Basically, you can just say what you want, and it's going to get done. No questions asked. So that is a nice thing about it. So let's go back to our examples and see what that really means. OK, first one, regex. So what I said here, you just describe what kind of pattern you want to match, and that's it. So you don't know the order it's going to be executed in. You don't know which algorithm is the regex using. You don't know what it's actually doing. You just know this is going to get done. So let's now imagine there weren't any regexes. You had to use JavaScript for this. So this is the kind of code you will have to write. So if this before was saying what you want, then this is definitely saying how you want it done. So for example, first you have to split it by @, you have to see the length, you have to check the domain. So this is super, super specified here. And imagine writing regex in a single line and writing all of this, You have much more space for mistakes. Cool, let's move on. Then this one is super interesting, SQL. So here again, you just say what you want. You don't know what's happening under the hood. But what's actually happening is that there is a thing which is called SQL, engine has a planner thing. So what happens when you specify your query, SQL planning part comes and sees what you want. OK, so you want this data sorted like this, organized like this, and it goes inside and sees, finds the best way to execute it for you. OK, I first have to go to this table, then I'll go to this index, and then I will do some searching and sorting. So it's almost like a route optimization problem. And it's very cool. Basically, again, you wouldn't want to do all of it by yourself. Also these changes. Whenever your database size changes or your structure changes, this is going to be changed. So it's almost like having, a senior engineer sitting in your SQL engine and doing all the smart stuff for you. You're just asking questions. And finally, our good old JSX. Again, I'm sure you're pretty familiar with this. But you can either write this, or if there weren't for JSX, you will have to write this. You have to do all the library calls and you use all the nice HTML syntax. And this is kind of manageable now, but imagine having a bit bigger structure. That would really become, bigger tree. We are not aware that we have with this. We don't care that we have a virtual DOM which is updating itself on the client. We don't know all of this. We are just writing HTML and we are happy. Cool. So this is why. First reason for DSLs. Why DSLs? Say what you want, not how. You don't care about the implementation details. You just want your stuff done. OK, there is also another cool thing about DSLs. So let's imagine two stories. We are taking one SQL developer from 20 years ago, and we teleport him, to today. and we show him our cool SQL code today. And you know, chances are he's actually going to be quite familiar. Like, oh, there is some new syntax, some new keywords, you know, but kind of the structure looks similar. He's going to be, you know, some new best practices, but okay, he'll probably catch it up and be productive in a couple of, you know, weeks, maybe months, I don't know, but he's going to be fine. But now let's imagine the other poor guy. You know, we take the web developer from jQuery time and we bring him today and show him all the stuff that we have today. So first, he's probably going to get like shit scared and probably try to run away. Then he'll use jQuery. Everybody's going to make fun of him. And finally, he will become a database administrator, right? You know, so that's how it is. So that is also another reason for DSLs. It's right here. So good DSLs are like Kino reefs. They age really well. And the main thing is what we described before. It is what, not how. Because we are just describing what we want. And what we want from our database is the same 20 years ago, it will be almost the same 20 years in the future. So this doesn't really change. Of course, there are going to be details, but the same structure is kind of going to stay the same. So that's another really cool part about DSLs. Okay, now let's get back to our main topic. As you know, we wanted to marry these two concepts. We know now what are DSLs, like what is, you know, some cool things about them, but we are back to our web frameworks now. So how do we marry these two concepts? So we said DSLs are really good for, you know, some domain which is quite easy to say what you want, but you don't really want to deal with the complexity of how you want it. Kind of sounds like web development, right? So this, you know, this seems like it might be a good fit. So let's see how we could actually go about kind of marrying these two together. So the thing we are going to be doing next, so we are going to be, you know, doing some imagining. So, you know, so let's try to imagine some of the features of web development and see how we could shape them in a DSL way and what benefits we could get from there. So I actually have one particular example, one feature in mind. I'm sure you're all very familiar with it. It's like a super scary thing that, you know, like many developers have lost their hours, if not lives on it. You know, you know, I think you all know what is it about. So I will just get into it. So it's this bad boy. You know, the good old SMOT, or authentication smog. So, you know, for myself, every couple of years, I have to re-implement authentication on some project, and I'm just lost. You know, it always looked simple from the start, but then you realize, like, there is a ton of new libraries, like, should I use JWTs or cookies? How do I handle sessions? There is always a new best practice, and I just have to get on the speed on everything. So, you know, just given on how we described it, this might be an interesting case for a DSL. So, you know, let's check it out and see how we could do it. So we'll just do some, you know, we just start from the blank page, and let's try to imagine how we could use a language, like a simple language, to say, you know, just what we want. Let's just focus on saying what we want, not how we want it done. Okay, so me being a web developer, you know, I'll try to start with something which is similar to JSON. You know, we just have our auth, we say, okay, this is going to be a space for specifying our auth stuff. Okay, this is what we want. Next thing is probably going to be, like, you'll want to provide some methods to your user, you know, to be able to log in or sign up. Okay, cool. So let's say you want to use username and password, and we want to provide Google also as a method. Is there anything else we need? Let's add a couple more things. We might want to specify to some, you know, our data model or table, and say, okay, let's use this data model for storing all the data about the user. And for example, we can also add some behavior settings. You know, if authentication is successful, you know, let's go to homepage or dashboard or whatever is the, you know, main thing for your app. Okay, so we have this in place now. And this is just saying what we want, not how we want it done. So can this really work? Actually, I have a working example. So let me show it to you how it works. Opa. This side. Okay. So here it is. Here's a bit more details on it. I'll just see if it's visible. Zooms in, nice. And disregard this part. Okay, so here it is. So this is pretty much the same thing you saw just a little bit before. We have our auth, we define our methods, and, you know, it's a bit more things, but pretty much the same stuff. And now let's try to run it. Let's go to our code, to our application. I built a special one for this. And let's do it. Let's log in with Google. Nice, I log in. And cool, my application is here. I came to Shift, I'm having fun, and, you know, I'm showing you auth. So let's keep doing this. Okay, this works. But let's say now I want more stuff in my auth. Let's say I also want GitHub as a method. Let's go back to our code. And let me just write GitHub, right? So what's going to happen? Okay, we go back. Oh, now we have a GitHub button here. And let's see if it works. Yep. Oh, okay, we have to refresh it. It's here. And basically, this is full stack. So everything works from client, from backend to database. Cool. So obviously, this can work in some way. Now let's back to our presentation and see what else we can do. Going back to this side. Cool. So we tried auth, but what else can we do? What other features can we push into DSL? How about we take a step back and say, like, let's make a concept for the whole app. So we have our app. It's called To Do. And let's give it some title. It's my shift to do app. This database is going to be Postgres. And now we embed the same old thing as before. Okay, so we have this. Sounds so good so far. Cool. We can also define maybe some data models. We call them entity, I call them here. So it has some ID, some fields, and similar. But now let's try to do something else. Let's try to do a page. So we have a page, and we say, okay, this page should live on this route. But how do we specify, the view? How is the page rendered? What is on the page? So that's kind of where it gets tricky. So we have two options. We are inventing a language, and we can do whatever we want. So are we going to invent our own language for this? For specifying how our page is rendered? We can. But is it really what we want to do? Like, is there maybe some other tool which is better suited for this? And that we kind of know already? So I stand corrected on my previous meme. It's not all the features, DSL, it's some of the features. So it's not the goal to put everything in a DSL, especially when you have other DSLs that we saw before that actually do the job really well. So how about we actually rather do this? So this is a way. We use our language again to specify what we want, but at this line on the component, we actually hand it over. Okay, now JSX take it over and you take care of it. And JSX, as we mentioned, is also a DSL. So now we have a really nice collaboration between multiple DSLs. Okay, sounds good. Let's see what more we can do. So now that we have all this together, this is the code we wrote so far. So it looks like a high-level specification of our application. We defined our app, we defined our page, our entity, some methods. It's like a pretty short, concise, declarative way of what we want from our app. So let's go with that. And actually, this is full stack, so this covers everything. Like, we don't have to think, is it only client, is it only server, and everything. Okay, so actually, as I mentioned, I have a working example, and you might have guessed this is WASP. This is the framework we are working on, and it's full stack. So let's go back to our code, and I can give you a bit more of a tour. So this is what you saw before, but actually the full thing is here. So again, we have our app definition. I define some versions, some stuff. There is a title. This is the auth block you saw before. And then also we have some more client modifications. But again, here, we can use NPMs. Like, we are not going to reinvent our own package library. You can use any dependency from NPM you wish. Then again, as we saw before, there is some routes and pages, and we are defining them. They can even be protected. You can say, no, this page is only for user. And then you will get your React component, you will get that user immediately, once it's ready for you. Cool, so we can do paging and routing, and we can even do database stuff. So here we are using PSL, another DSL, so Prisma Schema Language, if you're familiar with that. So we are not going to reinvent our own language for data models. There is one, it's called Prisma. So again, we are using it here. And we have the same thing going for backend operations and mutations. I will not go into details, but it's also, basically we just outsource it to Node.js. You can define your function and use it. Nice, it also, we can play a bit with our app again. Oh cool, I showed you auth. Play around with an app. So all of this is actually happening full stack. Everything comes to the database, goes back, so everything is sorted out. Okay. Back to our presentation. So what now? So what we actually just saw, the way that in WASP works with is actually it acts like kind of a glue between different technologies that you already know. So you have your React for front end, you have your Node, for example, for the back end, and you have Prisma for the database. And WASP is also a DSL, but it's not trying to replace this. It just works together with them and kind of does all the connection between. And solves a lot, part of the typical repetitive. You have to reinvent like auth, APIs, and all that similar stuff. So this is a kind of high-level definition, but if we go a bit more technically, this is how it looks like. So on the left side, what you see, these 3 files, is your project. So there is a like main WASP file, your configuration file, that one that you describe all the specification you saw and all that stuff. And then additionally, you plug in your custom logic. For example, here in JSX and Node and similar. And then we have this thing that was written in Haskell, our WASP compiler. So what happens here, compiler gets all this information and kind of acts like a SQL planner we saw before. It sees everything that you want to do. It knows all of your requirements and then decides which code to generate on the right side. So this basically you never touch. This just keeps regenerating with every change you make. But this is what happens under the hood. So right now it's generating React and Node, but you can have multiple targets even. It can be adjusted. So that's the power of DSL. You have this knowledge to stop before deciding what to actually do. So let's see what else we have. Interesting part to show you is actually what I said what was generated. So let's check it out a bit in our code. Okay, so let's go here. So this is a hidden folder right here, .wasp.out. So this is what happens. What is generated from this file and a couple of other files we saw is we have whole database code, server code, and web app code. So for example, if we now check our server code, so everything is here. Let's go to source. Let's see odd stuff. So for example, all of this is created in Node for odd stuff. We have different providers, configuration, local, auth. So all the setup is made here. Nice. Similarly is done for the client. Let's go to our web app, migrations, our web app. Again, for auth here, we have forms which are done for you. We have helpers, pages, the whole initial logic, types, and similar. So I mean, all of this, if it weren't for this, you would have to write by yourself if you were going to roll out your own auth. Okay, so let's go. And one more cool thing that one of our colleagues just developed very super recently, we can have a nice visual representation of what WASP actually knows. So it's right here. We just imagine what we saw in the file. So this is what WASP sees. It sees everything you defined. There is our main app. This is configuration. Then we have our entities here, user and task. We have our routes. And so WASP understands how they're all connected together and what they should be doing. It knows those concepts because it's specialized for web application development. So let's go back. Oops. Nice. What else? So I mean, today we still live pretty much in the how world. We have to know and we have to decide, like, do we do SSR, SHD, do we run something serverless, do we write on server, do we write on edge? Like, this is all how stuff. We don't actually want really to know that if we don't have to, but we have to. But the power of DSLs, which I just showed you before, they enable us to cross that realm into the what world, what realm. So we could actually say, like, look, this job is like resource intensive, and get care of it, take care of it. Or this is a long running job, like make sure it keeps running for a while. Or this should be optimized for SEO. I don't care is it SSR or not or something else, just get it done. So this is where we want to get, and this is basically what we are trying to do. So now is the time to talk a bit more about what we are doing. So all that you have seen, actually that is WASP. So it's a full stack web framework with its own configuration language, which works together with React, Node, and Prisma right now. So we have been in beta since the beginning of the year. We had over 15,000 applications created so far, pushed to production. We recently even had the first company or project which was acquired, which was made in WASP. That was kind of a big milestone. And we were backed by Y Combinator and other investors. And the cool part, of course, everything is open source. Everything is fully open source, and we are getting close to 4,000 stars. So thank you very much. That was it from me. Before you go, we have a bit of a raffle going on. So if you scan this code right now and give us a star on GitHub, you will enter a raffle to win a cool keyboard, especially WASP themed. And also make sure to follow us on Twitter, because that's where we are going to announce the winner in a couple of days. Also, I'm going to be here all day today and tomorrow, so find us at our booth. We are in the startup section. We have a cool arcade you can play, get into raffle, or if you want to fight me about frameworks, say me everything that I need to know, just find me and I'm happy to meet you. That was it. Thank you. Yeah. Do they take me off the stage?
part was it ended. September 3rd was the last direct flight, only for the summer they have.
Okay, everyone, put your hands together if you are still here in the room. Give us a round of applause if you're still here in the room. There we go. You're the hardcore people, right? You're the people who stayed right till the end of day one. And I'm assuming will be the people right here early in the morning on day two as well. But we have one final speaker to go, and I'm really excited to introduce him, actually. I was just having a chat with him down there, and he said, as well as all of the things that he's ready to talk to you about, Sohan has represented his country before in a sport. So I want you to give a guess as to what sport that might be. Maybe he will tell us himself. I'm not going to tell you because he told me. I'm not going to tell you what sport it was. Hopefully you will tell us, Sohan. But let's give a huge round of applause for Sohan Maheshwar, our final speaker of the day.
Check. 1, 2, check. Hello, can you hear me? You all are the hardcore people for sure, so I'll try and make it worth your while. My name is Sohan Maheshwar. I'm a dev advocate with a startup named Fermion. I spent my last 6 years at Amazon Web Services, AWS, working on cool cloud stuff. And today I'm going to tell you what the future of cloud is. And that, folks, is WebAssembly. Has anyone here worked on WebAssembly before? Anybody? A couple of people, excellent. So we're here to talk to you about why WASM, or WebAssembly, is the future. First off, I know this is a very bold claim to make, right? I'm just walking on stage, random person you've never seen before, and I'm telling you the next wave of cloud computing will actually be powered by WebAssembly, right? So I know it's a bold claim to make, but stay till the end and hopefully you're convinced. But if you don't believe me, you can actually see this tweet by this guy named Solomon Hykes. And he says, if WASM plus WASI existed in 2008, we wouldn't have had needed to create Docker. Solomon Hykes is the guy who was part of the team who invented Docker. He's known as the person who invented Docker. So I think he has something to do with seeing what tech works in the future. So of course, this tweet is part of every WebAssembly presentation you'll ever see because it made such a big wave, right? And I thought I'll also quickly add it up there. Today, I'm essentially going to tell you about what WebAssembly is, how it works, how and where you can actually use it with a quick demo with an open source project. And I'll talk about how this will change things in the cloud and how this may affect you in your companies. Right? So a bit of history now. WebAssembly, the boring answer is it's just another bytecode format. Right? It's another portable format of things that you can run somewhere, right? Eventually, it's all zeros and ones. But how is it different, you ask? Well, essentially what happened in around 2015 was a bunch of companies got together, and they decided they wanted a new format, right? And this format was meant to run things in the browser much faster and more safer. And essentially, they came up with WebAssembly. And WebAssembly has a smaller instruction set. It's much more of a low-level language, so it's faster. Right? And it's designed to be portable, which means it can run anywhere. Originally, it was meant to be run in the browsers. In fact, you still have companies like Shopify, Figma, Adobe, who use WebAssembly for their front ends for it to be faster and safer. But it can also be used outside, which is what I'm going to talk to you about. Essentially, it runs on a compile once and then run in any number of targets sort of model, as long as it has a runtime that can run WebAssembly. Now, the slightly older folks in the room, like myself, might be like, hold on, isn't this like JVM or Java Virtual Machines? And conceptually, yes, it is, in the sense that you write this once, you can run it anywhere. But the key difference, we think, is that JVM is proprietary, whereas WebAssembly is not. It's a technology, it's a standard, anyone can use it. And of course, it is security sandboxed by default, which I will talk about in a bit. And a quick FYI, WASM WebAssembly, same thing, right? It's the exact same thing. How it works is, like I said, you have some code, and that code can be converted into a WASM format, which can then be run anywhere, right? So you can run it in any machine that has a WASM runtime. And this could be a Mac, this could be Windows, Linux, Intel, ARM, AMD, Kubernetes, Raspberry Pi, cloud, whatever. You can run it as long as it has a WebAssembly runtime, right? So that's one of the big advantages. Just to give you an example of this, here's an example, but only I've just used screenshots of how a Rust app is actually running in the browser with JavaScript, right? So you can see Rust code there. The first line is something called wasm_bingen. That essentially is a library that facilitates high-level interactions between WASM modules and JavaScript. Right? So using that, you can have access to the DOM, or the document object model. There's just some text and a small calculator at the bottom. Right? Don't have to worry about it too much. We have JavaScript code that actually can send values to this particular Rust code that's written there. You can see the tree and the source code. You see there's a TS file, there's a JS file, there's a Rust file, and this can actually run in the browser. Right? Now, some of the things that made WebAssembly really good in the browser were what I just mentioned to you. Right? It is cross-platform, it is cross-architecture, so write it once, it'll run anywhere. By default, it is security sandboxed, which means any WebAssembly module, nothing can access that module unless you give it specific permissions, right? Unless you explicitly say that, OK, you can access this HTTP host or this file, nothing can access that WebAssembly module. So it is security sandboxed by default. Also, the binary sizes are very small because it's very low level. And at the same time, it's a reduced instruction set. So the execution time and the startup time is very fast. And ideally, it can support any language. All of this makes it good for the browser, but it actually makes it great for things on the server. Because at some point of time, I think around 2019, people were like, hold on, all of this will make WebAssembly amazing if you can run it on the server. The thing, though, is if you want to run something on the server, you need to give it access to files. You need to give it access to things like sockets and networking and clocks and random number generators. Right? So in 2019, something called WASI was launched, which is a new kind of system interface. It's WebAssembly Systems Interface. And the TLDR essentially is it allows you to run WebAssembly outside of the browser, i.e. on a server. Right? And suddenly now you have this new way or this new idea of running WebAssembly in the browser, in the server. What it does is it gives you access to OS features like files, file systems, clocks, random number generators. It's completely independent of any web API or any JavaScript, so you can run it in the server side. And the security sandboxing also includes, the WASM sandboxing is also extended to include the I/O. Right? So the same security model has been preserved. Just to give you a recap, you have JavaScript runtimes, of course, like V8 and SpiderMonkey, that allow you to run WebAssembly in a browser. But now you have these new runtimes, like WASMtime, WASM Edge, and also an experimental Node.js runtime to start running WebAssembly on the server side. Just for some context, this is the evolving language support in WebAssembly. This is a page that constantly evolves, and I have to always change my slide because people like me, I work in Fermyon, but also other companies like Fastly and Microsoft work together with different boards and foundations to get support for WebAssembly in different languages. So it is something that is constantly evolving. Lower-level languages like Rust, C, C++, of course, have better support because they are lower level, whereas languages like Python, JavaScript, TS, all of them TypeScript, the support, I think, is still in a state of evolution and will definitely get better moving on. So I've given you this overview of the history of WebAssembly and why you can now run it in the server. How can you actually get started by building your first WebAssembly app? Right? And getting started with WASM. So I work at a startup called Fermion. Basically, the founders of Fermion, about, I think, a year ago, started writing an open source project called Spin. And this caught fire online. Currently, I think more than 4,000 stars on GitHub, huge community, Discord, all of that, where people essentially write libraries to build WASM apps using Spin. And we are trying to build the developer experience around building WebAssembly apps. So Spin is the open source framework. It's an open source tool. It consists of libraries, templates, and a CLI. And you can just create WebAssembly apps if hosted wherever you want using Spin. Right? So I can show you a quick demo of going from nothing to creating a Spin app just using 3 commands. Right? And hopefully this works. You know how live demos go. So I'll say a small prayer to the demo gods first. I've already installed the Spin. Oh, wait. I need to move. We already started. Hopefully you can see my screen. Yeah, there we go. Yeah, so I've already installed the Spin CLI. So all I have to do is say something like spin new. Right? And this gives you a bunch of templates for you to get started easily. Now, for any WebAssembly app on the server side, we envision something that is always event-driven. Right? So anyone here familiar with serverless computing? Anybody? Lambda, Azure? Yeah, many of you all. So something very similar where there is an event that this particular WebAssembly app gets, and then some code actually runs. Now, that event could be anything like HTTP, which is the first few examples you see. It could be a Redis trigger as well. It's open source, so people have written triggers from SQS, Simple Queue Service. People have written triggers from MQTT. But I can show you a simple example that is in HTTP and in Rust. So we can do that. I can give a name. So let me say Rust_shift. Right? Description. A HTTP base is basically a route. So if you do something.com/rust, this particular app will be triggered. So we'll say, sorry, that's the path. And that's it. So let's see how that actually looks. CD. Oh. Yeah. OK. So basically, what this does is it creates something called a cargo.toml file. If you're familiar with Rust, you know what that is. And it creates another manifest file called spin.toml. Right? And we will look at that now. Essentially, this is the entry point to your Spin app. Right? And hopefully, you can see it. A WebAssembly app and a Spin app is made up of multiple components. And in this case, you have just the one component that you've defined here, which is what you can see. In this component, you define an ID, line number 9. You also define the allowed HTTP hosts. Like I said, WebAssembly, by default, security sandbox model. So if you want to say only xyz.com can trigger this particular WebAssembly module or component, you can mention that in the allowed HTTP hosts. In this case, of course, we put a star, so anything can trigger it. But you can specify which hosts are there. Right? And you can see below, this is the route. But you can also specify a route when this particular event is triggered. And of course, the source code is super simple because this is a simple router. So it is a request-response model. A request comes in, line number 9, and a response goes out. Right? We can actually just change this to hello shift. Let's see how that goes. So this is my Spin app that I've created using Rust and WebAssembly. If I do spin build, this builds this particular app locally. It uses cargo and all of that to build the app locally. And you will see that it creates a .wasm file, which is the WebAssembly module that can actually run anywhere. So once this is done, and it took about, 10 seconds, you will see here, right, there are files here that are created that can actually be run anywhere. So let me actually test this out locally, right? And all I have to do is spin up. And this creates a local server. Oh, sorry. I think I have something running already here. Control-C. There we go. Yeah, this has actually created this locally for me to test it out. Yeah, you can see this here. So I have a local dev experience for me to test out my WebAssembly app. Now, we want to build the entire dev experience from building a WebAssembly app to pushing it out into production. So Fermyon, we have a cloud product as well. So I've integrated my CLI with the cloud, which is a one-click thing through GitHub. So all I have to do is just say something like spin deploy. What happens now is this app is going to be pushed to the Fermyon cloud, where it is actually live and in production. Of course, this is a simple Hello World app. But even with this app, you can see that in less than 66 seconds from start to end, you can have an app running in the cloud using WebAssembly, right? And yeah, there you go. That's the address. You can also bring your own custom domains to this for now, right? So here you go. Yeah. So this is an app that's live in the cloud. It's in production. So we've built the sort of end-to-end experience for building out WebAssembly apps. I'm going to switch back to my presentation right now and talk about why this is so important, right? And it is because of few things, of 4 things specifically. The first one is the size of your binary file. Now, all of us are devs. I think we frequently talk about things like optimization and improving things like packet size, binary file sizes. In Rust alone, a typical Rust Hello World compiled to WebAssembly is only 2 MB. Right? If you do it natively, that's typically about 3.1 MB. And if you compile it ahead of time to a particular architecture and OS, you can bring that down to 300 KB, right? Which is really, really small. And that makes it that much more efficient in terms of resource utilization. At the same time, a basic spin HTTP API that I just showed you, the just-in-time compilation is 2.3 MB, and the ahead-of-time compilation is about 1.1 MB. Right? And these things make a difference when you're actually serving customers in the millions and doing things at scale. The next one is startup time. This is the trade-off between binary size and startup time. If you compile a program in Rust natively, it is a little faster. So actually running it is about 2.3 times slower than doing it natively. Right? So it is a trade-off that you as a developer or as an architect have to sort of think of making. In terms of portability, I said again, you can build this once, you can run this anywhere, and the same build sort of works across OSs and across platform architectures too. And like I mentioned, security, by default, it is sandboxed. So you don't have to worry about external things accessing your modules or your functions that are actually running, because it's default sandbox security. So I've given you an overview of the history of WebAssembly, why it's good in the server side. How will this really change cloud computing, though? I think most of us work in the cloud at some level or the other. How will this change in the future? I think it'll change things gradually and then suddenly. So 2 ways that I see it change cloud computing, but we have to look at the sort of progression of cloud computing in the last few years. I think we all started with the heavyweight, which is virtual machines, things like Amazon EC2. These were entire OSs that were running in, quote unquote, somebody else's computer, right, running in the cloud. And these took minutes to start. As a dev, you had to do updates, maintenance, patches, all of that. So the dev experience wasn't great, but it introduced us to new forms of computing in the cloud. I think sometime in the mid-2010s, things changed to containers with Docker and Kubernetes. Here you had applications which had dependencies, but you never had the, it's working in my local system, but not in production, right? Because you were shipping things in a container as well. This takes about a few seconds to start, so it's much faster. But at the same time, the developer experience is good, but it can be complicated. I think anyone who's managed an entire Kubernetes toolchain will agree with me that it is kind of complicated. The sort of shift everyone's talking about now is the shift towards serverless, right? With things like Azure Functions and Lambda, where everything is completely event-driven, and things take milliseconds to start. And as a developer, you don't have to think about patching, maintenance, scaling up, scaling down, and you're paying only for the time your code is running. The thing with the current day of serverless is there are still some problems which we intend to fix with things like being platform neutral and building a good dev experience. So let's talk about a bit of both right now, right? Let's talk about containers. Containers can be clunky sometimes, right? If you've used Docker and you have a huge Docker image for a simple program, you know what I'm talking about. We actually tried doing one of those things, and I'll show you the benchmark. But this is the follow-up tweet to the original tweet, which is, so will Wasm replace Docker? The answer is no, right? But it will probably run alongside a Windows container and a Linux container, or it might replace it, but there's still space in the world for containers. How we see it basically is this, that it is a fast friend with containers. So here's an example of a Flask app in Python running on Docker, and the same thing sort of built using WebAssembly. Right? This is the visualization of the size of the Docker file that's built using Flask, whereas this is the same program using WebAssembly. Right? And we also did a benchmark, and the size difference was 23 megabytes to 550 kilobytes. Again, as programmers and architects sort of optimizing on processes and resource utilization, these things make a big difference. So we really see containers and Wasm working together to, again, make that container size smaller to be a little more efficient, right? Docker Desktop 4.21 onwards supports Wasm. It's still in, I think, beta/preview mode, but there is support. You can also run Spin on Kubernetes. There is support on Azure AKS. There is a module called KWasm that does this. And we're working with many other Kubernetes providers to actually have full support for Spin. So there may be instances where your workloads might actually benefit from moving to a WebAssembly that's running in a container somewhere. So that was the containers bit. Let's talk about actually fixing the current state of serverless. I love serverless. I think serverless is amazing and definitely the way to go. In terms of widespread adoption, it still isn't as widespread as, say, just cloud computing. So we're still seeing enterprises adopt serverless. The thing with serverless is the definition is still quite hazy. So we like to think of it as a pattern for coding where the developer like you does not write a server process. So you're not writing a socket or a daemon. Yeah? And the entry point usually is an event. Now, in the serverless world, there are a few things that can be improved. And the first thing that people talk about in serverless is cold starts. So essentially how this works is when an event hits a serverless function, say in Lambda or Azure, that program has to be started up, which takes a finite amount of time. And in applications where that is critical, devs try very hard to reduce those cold start times. Because we've been able to run it on WebAssembly, which has a smaller instruction set, a smaller binary size, it can have pre-compiled code, it has a lightweight runtime, the cold start time has actually reduced from 250 milliseconds on Lambda to around 50 milliseconds on WebAssembly and Spin. Yeah? And that, I think, is a fairly significant difference. So thanks to how WebAssembly is architected, thanks to how Spin is architected, you can bring those cold start times down to quite a bit. All right, so cold start is one problem. The sort of big problem we see when we talk to customers about serverless is the fact that big companies are afraid of something called vendor lock-in, where you are locked into a public cloud because you're using their serverless offering. Because there is no famous non-proprietary framework around serverless. If I'm not mistaken, there are a couple open source ones. They don't have widespread adoption yet. But essentially, this is how typical computing in the serverless world looks. If you have a function in Azure Functions, your other serverless functions are also in Azure Functions. If you have it in AWS Lambda, then you're talking to other AWS Lambda functions, and your microservice architecture is built around that. Or if you're a little more low level, your container is in like an OCI, Open Container Initiative, or Kubernetes, or you're running it on a virtual machine, and you're just stuck doing that. Right? We want to sort of move away from this proprietary locked-in type of serverless in the open source space. So essentially, we think that WebAssembly opens this up for y'all. And the last thing about serverless, and I'm going to give you an example of how it fixes vendor lock-in and this, is that you can have more than one language in your app. So imagine you're writing a microservice architecture where one microservice is in TypeScript and the other is in Rust, and it's talking to something else that's in Python, right? And WebAssembly can actually make this possible, and I'm going to show you a demo of that right now. The demo I'm going to show is something that I'm super excited about. It's called the component model, and you'll probably hear about this in a bigger way very soon, because it's something that's being worked on by the Bytecode Alliance, right? That is the alliance that's working on the standards around WebAssembly. So essentially, in a component model, you can use a component from anyone in your app. So say I'm writing a serverless microservice app, and I want to use a key store, key value store. I can use someone else's key value store without knowing how that operates. Someone else can use an authentication component that I write without knowing how it particularly works, right? And WebAssembly allows for that. So how that would work is you have these things called worlds, right? So I have a component, and in this component, I want a WebAssembly module component for HTTP requests and for a key value store. But I don't want to write my own, so I can just use someone else's HTTP server component and a third person's key value store component in my own app, right? And this becomes part of my world. So this component model, we think, will really open up how microservices and serverless truly is written. Of course, you can try it out. It's already live, but you will see a lot easier and better dev experience around it in the coming months, right? Spin, the open source framework that you saw a demo of, already has something like this, where you can export components for usage elsewhere. And yeah, instead of me explaining this to you, I can actually just show you a quick demo, right? This demo, again, is super straightforward in what it does, but how it does it, I think, is very impressive, right? So let's take a look. So this is a simple key value store. I can add a key and a value, right? Again, very simple. Oh, I'll have to start the server, so just give me a second. I'm just starting this up locally. Yeah, there we go. So this is my key value explorer. I say conf shift, right? And it's added it to a local key value explorer. It's just a simple key value. Don't worry too much about it. And I have a web page that's running here, which essentially I can call a service, and it pulls up that same value, right? So this is a simple CRUD database app. It's not very impressive. But let me show you the code behind this. As you can see in not this code, yeah, this is the code. There's actually a Rust file talking to a TypeScript file to get this done, right? What you see, which I think, again, is impressive. So if you see the front end for this, the time I press the first button, it actually get and set a value from my Rust file here, right? So I set the value using my Rust file, and I got my value from the TypeScript file here, right? And again, this is the future we sort of envision with a microservices architecture. If you look at our, like I said, the manifest file here, there is a component which is a Rust component, which has a route, and it has a key value store. That key value store is automatically synced to an SQLite database that is triggered here, and that talks to my TypeScript component, right? So I have a Rust component talking to a key value store. I have a TypeScript component talking to an SQL database, and those two are talking to each other in the same app. So I've exposed all of that, using WebAssembly. And this, we think, could be the future of how cloud computing actually works, where you're focusing on the core business logic, the dev experience is great, and the cold start times are very minimal. In terms of the sort of use cases that this actually opens up, I just showed you things in the cloud like functions as a service, but also things like plugins for user-defined functions in databases, or bring your own code in a SaaS platform. Say you have a SaaS platform like HubSpot and you want to bring your own code that runs a webhook somewhere or a Slack bot somewhere. This is ideal because you have the very fast execution times, very small binaries, and you can write it in different languages. And in things like IoT, you can run WebAssembly on the edge as well. Again, in smaller IoT devices, which will run and make it a lot faster. So it really started to open up so many of these new different use cases once Vazi was done. Anyway, hope you learned something about the WebAssembly world. I'd love for you to check it out. Spin is open source. We have a Discord and a GitHub, vibrant community around it. So if you do coding in any language, you can get into building in WebAssembly because, well, that's the point, I guess. So do check it out. And yeah, I'm here for the rest of the conference if you have questions. I have some stickers and T-shirts in the front if you want to grab some. There are limited ones. And yeah, thank you for having me. Cheers.
Okay, everyone, thank you so much. Let's have another round of applause for Sohan as he leaves. And thank you. That brings us to the end of day one of Shift Conference. There are obviously other things happening elsewhere. Feel free to check those out. We will see you again tomorrow morning. So thank you so much for being here, everyone.